SINCOM is on the board, so we work closely together there. I'm also very happy. The Heeg organization is a premier partner for SINCOM, and we work with Georg, with a lot of our customers, with a lot of different opportunities. He's probably going to talk about some events that we work on with him. I can hear myself perfectly fine. But I don't want to take up too much time. I just want to introduce Georg. He's got a really interesting talk to give you. I think he's going to do most of it in English, but he might slip in and out of different languages. If he does, just give him one of those looks, and he'll slide back into English for us. So join me in welcoming Georg Heeg.
Yeah, I said hi so many times that I won't repeat me, so I would like to talk about Eurydike today. And you might ask your question, why didn't I call it Eurydike, or Eurydice? That's all the same thing, but in Old Greek it was Eurydike. Okay, so she was the woman of Orpheus. Okay, so I'm now speaking as the executive director of STIC, but as our company manager, we have 2-3 locations, and I brought 2 of my colleagues with me, and we are around for more than 25 years now, as we celebrated our 25th anniversary on the 7/7/2012. So there's actually an after-the-fact constructed acronym for Eurydike. Easy, usable, relational, yobbish database, intuitive, key mapping-less environment. So, yeah, that's what I'm going to talk about. So what are the things it shall do? It shall talk about object relational mapping and objects and databases. So you certainly recognize this picture as has been shown several times during this conference. The main thing of objects are that they are live, that they respond to messages, and that they have their own identity. That's it. One thing which has been discussed over and over and over again, and whether you do Dart or Java or C++ or Objective-C or Simula 67, there's always the question about persistence. That's actually a pretty old, I assume IBM something, to store data. And the question about persistence has 2 things. One is, how do I keep my data for hundreds of years, or how long I want to have it? And how can I handle multiple users? These are the 2, but they are totally different, but some sort of related questions. For objects and persistence, there has been old ideas. So since Smalltalk 80, and this is actually a screenshot from the Smalltalk 80 times, there was a thing that you could have this workspace and the image and save it to disk. So as you saw last night, I was showing you an image which was created in 1996 timeframe. So after 20 plus, or almost 20 years, you still can run those images, because what was in the image and what were the live objects, by then you can do this. And you can also give it to other people, and so many people can use the same stuff. So you have some sort of multiple users, but what you don't have concurrent access. So if I change something in my image, it won't change in yours. Another thing which has been around has been serializing objects. And there was one company, and we heard a lot, and I see Norm here in the audience. The other gen talkers I don't see at this point in time. They had the initial idea of do something about it, and this is not actually Norm, that's Alan and Monty, whose names I put there because these were the first 2 I met in the old days. So they were going on with the topic of persistent currency from day 1 on, because that was their concept. And they actually later came to Smalltalk and are using it since then. So they have transaction-based synchronization. So there have been solutions all over the time. Another thing is serializing objects. So making strings out of objects has been around forever. So like store string is there in any Smalltalk. Where the downside is cyclic references. So if you want to run a store string of an object that indirectly references itself, it will run forever. But Hubert Baumeister, who now is professor in Aarhus in Denmark, solved that problem, and he introduced keys and identity dictionaries and said, okay, if I have an object that is already there, then it's done. Later on, the same strategy was used in BOS or in parcels or in MOS or in XML or JSON or other kinds of serialization. There are so many. Some of them are XML based and many of them are much older than XML. But there's one issue with these serializing objects. You can store all or nothing. So you take an entire object graph and dump it out. They have no concurrency, and so there is a desire for databases also for coming that side. So we have this picture that there are databases around, that there is Gemstone around, there are object models around, there are even object relational databases around, and mappings. And let's look into relational databases. From theory, and that's why I put on here the picture of Mr. Codd, who did the original work. He starts with finite sets, a finite number of finite sets, and the equality of values, and builds cross products, and that's what he calls tables. And everything you can do, you can say, I would like to have this column of that table being equal to that column of that value. So we are looking for everybody whose postcode is the same as his yearly salary. So we would be in very bad shape. Our salary, our postcode status is 0. Okay, so it has nothing to do, and this is so different, and there have been old books around with the analogy of dismantling a car to put things in there, etc., etc. But still they are all everywhere, the relational databases. So let's have a look how you can map them into object and vice versa. One direction is pretty straightforward. As with objects, or with Smalltalk and more precise, you can map anything where you have words for, and as Mr. Codd described relations in a pretty defined mathematical way, it's very easy to report them into Smalltalk. So you map tables on classes, okay, and then the columns are the instances, the columns are the instance variables, the rows are the instances, and virtually every Smalltalk has a map of technology like that. So Object Studio has it, call it database support. It's not even POF, it's underneath. EXDI is there. GemConnect for Oracle is around. VA database support, and the other Smalltalks, except for Squeak and they have very limited because they are not interested there. The other direction turns out to be much more interesting and much more difficult because relational databases are so primitive. But there are object relational mappings around, and we will see later on that one of those who worked on this is with us right now. And they typically do go one step higher, and they take object networks and entity relationship models and map those together. I also went back to history and found the inventor of ORM, Richard Steiger, when he worked at Park. Who else should have done it? And the quote I have here is from his current LinkedIn presentation. So go to LinkedIn, search up for Richard Steiger, you'll find this picture and the quote which is here. I met Richard Steiger in the early days, and he worked for Park Place, and later on he founded his own company. called Ensemble, and he is the original author of Object Lens, which still sits. It has been deprecated 15 times in 10 years, but it's still shipping and it's still there. What it basically does, it uses sort of a typed Smalltalk and edit data entry validation and program transformation inferring and all nifty stuff which still is around. And so the next thing, and you have heard who these people are, and these are more current pictures. Actually, I think John is still the president of a football team in Ottawa, Canada. And Alan was with them when he was named the architect earlier today of Toppling in his presentation. So Toppling was available for multiple Smalltalks to do not very dissimilar things. It goes a little bit further than Object Lens, but still it is to have it easy to be mapped. And finally we have a picture of Alan, smiling as he does right now, Glor as the generic, lightweight object relational persistence. And the goal is to provide simple, powerful framework for reading and writing objects from relational databases. And some or a lot of the concepts are the same as in Toppling, but there are also some differences. But I don't want to go into details. So what all do they do, these mappings, which have been around for many, many years? They map entity relationship into objects. Change is rather painful with all of them. You have to change the classes. You have to change the tables, which comes in two parts, schema migration and data migration. And you have to change the map. So that was the main reason these three people, Georg Heeg, Doris Müller, and Olaf Urban, at a company called CAI, and later on Component Studio, had the idea they want to make had the goal of making the change easy. So when they were at the customer side and they had a change of their model, they just didn't have the time to migrate the database because the customer wanted to continue running. So the only chance they were having is changing their application. So they designed, and they are running this product, the ERP system Component Studio, and so they wanted to keep the database as it was, regardless of the schema. So that, and the way they did it, they said, we have one schema for all the objects. They actually based upon Object Lens and made two object lenses, one on top of the other. So there's one thing that does the real objects, the application type objects, and there's a mapping there to the objects which represents the tables, and there's another mapping from these objects representing the tables to the real database. And they have a limited number of tables in the database. This is one of them. So each object has an entry in this table consisting, they have a few more, but I just took the most important columns out of there. There's user in there and dates and stuff which don't really care. So they say, if I have an object and I want to have it in a database, it has to have a global ID, which is the object ID, and it has a smaller class, so domain model class. That's the thing which is written for any object. And then for every attribute, the attributes are typed. So for every attribute, for every instance variable of that object, they write to a different table. And there's one table per type. And the most important one is the object reference type, and this is basically a foreign key to the object referenced by this instance variable. So attribute is the name of the instance variable. Base value is the ID of the object that has the instance variable. Now that's my instance, and base value is the foreign key to the other guy. So it's just a relationship between the objects attributed by the instance variable name. And when you look at this, it is basically the same table, but it is integer value, so the only difference now is that this thing is taken as integer. So there are, I think, 50 such tables. So for each of the primitive data types, they have a different table, like attribute, arbitrary string table, binary value table, Boolean value table, large string value, tiny string, timestamp value, etc., etc. But our dream, so why do I speak about it? Well, we purchased this technology with the ERP system 2 years ago. That's why we know about it, learn about it, that it's smart, but it it's not a Smalltalk solution as Iron defined Smalltalk ... 2 days ago in his presentation in the other room. It doesn't feel like Smalltalk. It is not intuitive for Smalltalkers. It is not easy to use. And what we want is persistence without pain. So, can we use existing RMS? So, can we use Glor or Orpheus? Actually, using Glor, you have to do a lot of explicit description in methods. So, and as Carsten, who is also with us, pointed out in one of his presentations on the former conference, you have these class for model XXX, where XXX is the name of another class. Methods in the descriptor systems, you have table for XXX, you have descriptor for XXX. And you have to do all of that, and when it comes to subclass hierarchies with different or maybe even conflicting things where you have to have different subclasses in different tables, you need to have special resolvers and consider a lot about it and do a lot of work. In Orpheus, you still have create a length description and typing for each class which you want to store. And there are restrictions to it. For example, if you have N-to-M relationships, it is basically impossible to implement them directly because they only use the reverse map, and reverse map is only 1 to n, not multiple to multiple, so you have to have extra in-between methods that do the in-between classes, and it's also, so again, quoting Ivan, it doesn't feel Smalltalk. So, and this one thing which Smalltalkers just don't like, it requires typing. So, and we want it easy, and we don't want to write any mapping. That was the dream. And when the last day of sending in a paper to this conference approached, actually it was the last day to submit a paper, we started that project. Said, okay, we claim we can do it. We did the name was changed later, so working closely with James and Jeremy enabled us to do so. So we could, the name wasn't there, so the name was Build Schema-less System for Storage of Many Objects in a SQL Database. Okay, and today I can tell you where we are now. So, the question is, what kind of tables do we need in the database? how do we do the invisible? So the Smalltalk doesn't want to see this mapping of the object to access the SQL. What about proxies? They shouldn't be visible, but they should be there, because otherwise you are back to serialization where you take everything. So without objects, without proxies, you don't have incremental stuff. What about the concurrency, and what about garbage collection? Actually, as of today, jumping forward to the end of this presentation, we got everything done in the meantime, while we are still working on the concurrency questions. The ideas Georg is having, who's working on this mainly, are there, and I will show you where he was when he had to stop working for a high priority customer task Monday this week. So the strategy we followed, and this is a typical strategy we also do in other projects. We define a direction and we try out multiple ideas. And we try them out, and so we had 2 ideas in this particular case. So we first started with the offers model and said, can we just use that one in making flexible? And the offers model with this a table per type just made the SQL unbelievably complicated, because for every object you needed to go to every table. And this is not very speedy, and you have to do left outer joins because of it might be not there, otherwise you get an empty result. So no. So we said, forget about multiple tables, we do with one table. And here is the table definition we started with. So we folded all the different types into a single table. So we basically had object ID, row ID is just if you have multiple rows for the same object, you want to address them. And the object class is the same as we saw before. And then we have string field key and string field value. So the key is the name of the instance variable or the index in an array, and the value is just the value of the appropriate type. Same with integer, reference. These are just the 3 I mentioned before, but as there are more than strings, integers, and references, we needed many more columns. And so let's start with an example. So we have an association which has a string as a key and an integer as value, and this is how it looks. So you have the object ID 1, row ID 1, classes association, the key, which is the instance variable of class association, the key A, which is the value. There we have the value, which is the instance variable of the thing, and the value 1. We don't have a reference for we don't. So that's the first object we stored in the data. Actually, it's not the first one we used, but the first one I can show you. And if you have one which has a nil in there, it just has no value, so we left away the value field, because things which are nil shouldn't be visible. So, and then now we have 2 strings, a key and the value both are strings, so we need 2 lines, one to store it there and the other one to store it there. Okay, so, and with all of that, you can, but another example here is self-referencing objects, so an object that points back to itself. This is number 4, where you have a key and a value, and the value has the number 4, which points back to here. So all that seemed to work as the first idea, not bad. So for sequenceable collections, we said, okay, we can put in the, for example, for class array, we put in the string field, the print string of the key. So for arrays, for example, it's just the string representation of 1, 2, 3, 4. And in this case, you just need 2 lines, because 1 is a string, 2 is an integer, so you can use 2 of them. And the same thing you can do with other sequenceable collections. Unordered collection like set are just stored in the way they are implemented. So that was all okay. Dictionaries are very simple. They are sets of associations. So it's a little bit complicated, but somehow it works. So the SQL you have to generate here, this is now a SQL which goes to, but the group IDs are and, so it is not quite trivial, but not extraordinarily complicated. But we found out that to generate the SQL, you need double dispatching. That is, for each database in the table, you have to create, you have to go back and have a special thing. As good as double dispatching is as concept, as bad it is as it has a quadratic growth of code. So if you have 2 classes, you have 4 methods, that's okay, 2 in each. But if you have 27 classes, you have 27 times 27, that's almost more than 400. So 410 actually. So I hope so, that's right. I don't know. It can't be 410, must be something else. So, but it must be a big figure. So almost every object could be stored. We could do select, detect, but it was not Smalltalk as I would say. And the 1-column pair per type made it too complicated to generate the SQL. And still we had schema migrations that people decided to create extra primitive data types. So just make it simpler. And that's something you always should do doing Smalltalk, make it simpler. Otherwise you will not be qualified by Ivan as Smalltalk something. And he goes that way to his engineers too. I know that. Pretty guy. Okay, so that means we should do more unification. And the idea that Georg had was to do every object as a dictionary. And so this is the new thing, the new table he got. And he said, I want 2 strings for every object. And I asked him, why did you use 2 strings? So 1 major and 1 minor. I said, I need this for numbers. So then I can go in and have, if I have 2 strings representing a number, I can do the mathematics needed in the database, so I can compare a half to 0.5 in the database, because the database knows how to do it. So the float is done in 2 printed integers, and the fraction is also done. That's the basic thing. Other classes could do it also, but this was the prime motivation. So this is what I just explained. So let's do the example again, and you see now we need more lines, and actually a table which shows also 8 columns. So it says also even the class instance variable, no, it's not an instance, it's a pseudo instance variable, is now stored as an instance variable, and it says we have a symbol, a key symbol, which is called class, and it has a string which is the fully qualified name of the class, of the object I want to store. And the key is also a symbol, the key instance variable is also a symbol, and its value is key A. And the same with the value, and this is a number, that's the thingy which is bigger, and the subclass of number. So someone called it the species. There was an arguing, I think it was Stephen who spoke about species as comparison idea. So this is the same idea, taking here the species and here the real class, and it's a 1/1. So integers are stored as floats to ease the math. Example 2 is the Neil. Again, the value is taken out as we don't need it, so that idea can across from the other one. The two strings, again here, another 3 lines, and you can do detects. So self-references you can do. And now the self-reference is done by object. So if you put in object, it is a reference to line 4, so to all the 4 lines which represent this object. So dictionaries can have, and other classes can do with these 4 columns other representations, as everything is stored as a dictionary. We have this in Dart too, haven't we, earlier today? Everything is in JavaScript, as you said. Everything is a dictionary, so that's a similar idea here. And so if I have a dictionary with 2 keys, so it basically simplifies the thing, and it stores the keys in the key columns and the values in the value columns. So all these methods, add key add value, keys can be translated, includes key, can be generated as SQL statements and generated and executed on the database. So as we return uniform data, the generation of SQL becomes much simpler. There is no need, on the other system you had to go through and turn forward and backward, and all this disappears. Contextual information is not needed. And when we need to make it fast in the future, at some point in time, we can still have room for optimization. Or as we are in the feasibility and research study, we don't optimize at this point in time. So, special objects. Byte arrays are base 64 encoded strings. Compiled methods, we can do the same tricks as everybody else, like parcels do or boss does. So either as byte array of compiled code or as source code. We haven't decided yet, we haven't used the block context. The same consideration to be done like in any other system, like OpenTalk when you transport things. So the main thing are the copied values. What do you do with copied values? Alan had an example earlier today where he can just generate closures on the fly, but the question is how to serialize them. So there need to be considerations to be done, how to represent that. But it's known technology and was not of a lot of interest at this short project, because it was not even a full-time project. It is, so this idea turns out to have some advantages over IDEA. Everything which worked there also worked. And it works easier and not. No, sorry for me. And but there is a but. Still, we have the idea that we have single objects in an unstructured way as collection of all instances of something stored there. That's not the way Smalltalk thinks. Version does it, by the way, that way. So they have this idea, but normal Smalltalkers, no, they have the root of the world, and everything which starts from there is accessible, and everything else not. Gemstone has the same. They have the namespace, the globals, I think they call them. And so here we call it the object space. And this is an abstract class, and you have to subclass from it and do something about it. So we do an example at the end of the presentation, storing objects. Objects have name, last name, and address. And they're a subclass of objects so that you can see there's nothing special about this person thing. And certainly we need an object space, and the object space has the superclass, the person space is a subclass of object space, and there we have one instance variable which takes our people, our persons. And we do a very simple solution. We take order collection new, so that's one instance method we need. We certainly need one class method, and the class method connection profile tells me to go to which database, in this case a Postgres database on my local machine, and the username and password are not really a secret. They are both Postgres on my local machine. So then we can create a workspace to create a couple of objects. In this case, Jörg Berger, Carsten Kuschel, and Manuel Schwarz, the people who worked for this conference in our organization. 2 are in Köthen and 1 is in Dortmund. And then we have something down here which we say to the object space committed, and that's what generates the database. I did not create tables. Everything is done behind the scene. This is the entire code I need to store the objects. And then I use pgadmin to have a look at the database. And believe it or not, it's 18 rows in this table. And this is really taken from that example, and it was really started with an empty database. The details, we don't have, I explained the details already beforehand. Now, we want to do something about schema migration. And this is a schema migration. This is 6 lines, right? So, we take the Persian space, and what we want to do actually here is convert the space from using a order collection to a space which uses a dictionary. Because we expect that we have more than people, this is about optimization, I know. You can always search an order collection, but we want to have that as a dictionary done. So what do? We create a new object dictionary. We go through all the persons in the database. We say in the dictionary we'll put at the key last name the person as object. So, who can read it as a Smalltalk? And then at the end we say, this dictionary will be the instance of, will become the new person's instance of our object space, and then we commit. And what do we get? We get the result. And the result is the new dictionary, which is, the dictionary is dark class. What? 17. 17 is the new dictionary. Yep, there it is. So, but what else do we have? We still have the order collection hanging around somewhere.
On top.
On top, the very end. So, what did we create it? We created garbage. So, what can we do with garbage? Yeah, okay, we can collect it. So, the question is, how do we do garbage collection? And if you do it, the order collection will disappear. So that's the proof of the execution. But I want to show you the entire SQL which is executed to do this increment. This is an incremental garbage collector, which is visible here. And it shows you, it deletes all the objects which are not referenced directly. So this will only destroy those objects which have 0 reference in the term of a reference counting. And you have to do this if you have multiple objects run multiple times. But there's, for easy things, okay, circles will remain. So we have another garbage collector. This is the global garbage collector, which will delete all objects, including references. This is the entire SQL to do that. I don't want to explain it to you, as I already got the 5 minutes signal. But it's not extraordinarily complicated. It's a single SQL statement to the database. So, where are we standing now? As I said at the very beginning, one thing we didn't do, or we're not able to complete, we discussed about it a lot last week, and Jörg worked on it on Monday this week. And so it is multi-user. I can tell you the ideas, but it's not completed. It sort of works, but not yet quite correct. So he said what we need to do is do some logging in the database and to have live connections so that objects are not cached, so that every time I want to access an object, it goes to the database, grabs it, and the idea is to do a semaphore-like global log in the database and to use, based upon that, to move on. This is still ongoing work. So why did we do all of that? Certainly not just for giving a presentation at STIC, although I love giving presentations at STIC, and we needed to have a topic, that's clear. But we came across a bunch of interesting tasks like that when we did this nice project of the Adventure World German language at Köthen Castle. And so this is an object where the one guy used JSON to store stuff, the second guy wrote his own XML and files, the other one said, no, I want to have the persistence in store, so I copy everything into objects and publish the objects. And then what happens, this is Daniel, he has to knee in front of a computer in the exhibition to fix problems. So that's really happened. And then there is this videos control, which has videos, and videos are so long, you don't want to store it in other ways. So we have this simple and medium-sized objects which needs to be done. And I want to thank at this end my team, and this is actually a picture taken at the 25th anniversary. And you see me doing my regular work, telling other people what they want to do, need to do. The story behind this is that this young woman, who is the wife of Roland Wagner, said, everybody in your company has its own little story.